the next one, we have a car traveling at 61 kilometers an hour, and it's brought to a stop while skidding 42 meters. What is the work done by the car by the frictional forces? So we need to go back and remember our kinematics unit and our dynamics unit, and now apply it to work. Okay, so let's think about it. Let's draw a free body diagram. There is no F-app because the car is skidding. So it's not turning, the engine's not going, or the motor, sorry, is not going to push the car any further. But the motion, it's still going in motion, and the force of friction is pulling back. Okay. Of course, we have our Fn and our Fg, but they're equal to one another, so I'm not going to put them in. Okay, now let's write out what we know. So I know mass is 1685 kilograms. VI is equal to 61 kilometers per hour. Now the shorthand way to convert to meters per second is to divide by 3.6. But if you don't know how to do that, either you have to memorize that or you have to do all of the conversions. So divided by 3.6 is 16.94 repeating meters per second. Or I will show you how to do the conversion. So we take 61 kilometers per hour.
So like kids even don't have to come to school? They can just stay at home?
This is what they're watching. Be quiet.
Well, that's what I'm saying.
No,
I'm
not going to be at school tomorrow.
So I don't even have to clean the classroom, right?
No, they're coming. You guys come to school. Okay.
Don't bother.
Here, I need hours and hours to cross off. How many seconds in an hour? 3,600. But now I still have kilometers, so I need to get rid of my kilometers unit. 10 to the power of 3 meters in every 1 kilometer. So you go 61 divided by 3,600 times by 10 to the power of 3, or just times by 1,000. So yeah, so we know our VI is 16.94. VF is equal to 0 meters per second. T is equal to 42 meters. We are looking for WF. So let's just make a road map of kind of how we're going to approach this question. So I know to find WF, the formula is FF times by D times by cos theta. Well, I wasn't told FF, so I need to find FF first. I can say FNet is equal to FF because there's no force applied going on in this question. The car is skidding to a stop, so it's just the force of friction. So now I can say, okay, well then Fnet I know is always M times A is equal to FF. But I wasn't told my A. So I need to find out my A using VF squared equals VI squared plus 2AD. So, and then I would solve for A here. So what we're going to do is we're going to do this one first. So that's number 1. Then we'll do this one second. And then we will do this one third. I mean, really, that's just our conclusion. And then this one will be third. Okay? So that's kind of the pathway that we're going to take with this question. Okay, so now here's part 1, or number 1. So VF squared is equal to VI squared plus 2AD. VF is 0, and I'm solving for A. So I want A by itself, so I put my VI squared on this side, divided by 2D is equal to A. So then A is equal to negative 16.94 meters per second. That value is squared, all divided by 2 times 42 meters. So A is equal to, so take time, put that into your calculator. So then A is negative 3.418, etc. meters per second squared. So remember, this is acceleration, so meters per second squared. Okay? So now, step 2. Step 2, we said that FF is equal to M times A. So FF is equal to 1385 kilograms multiplied by the A that I just found here. Okay? So that's negative 3.418 meters per second squared. So then FF is equal to negative 4733.966, etc. newtons. So now notice again, this is negative, which makes sense because the force of friction is acting in opposition to the motion. Okay, now step 3. The work due to friction is FF times by D times by cos theta. So WF is equal to negative 4733.966 newtons multiplied by D, which I was told was 42 meters, multiplied by cos of 180. So put that into your calculator. So you should get negative 198.826 joules. Sig digs negative 2.0 times 10 to the 5 joules. Okay, so you can move on to the next video when you are ready.